we are going to begin discussing how we can add BDD logging. So this will be the first thing that we are going to integrate into our framework. And I'm also going to use this time the native support for the observer pattern in C#, utilizing the event and delegates. But before we move to that, let me show you how we actually integrate that into our tests, how everything connects together. Chrome Developer Tools protocol is a set of tools that provide the ability to instrument, inspect and debug and profile Chromium-based browser. Hi guys, greetings from Bulgaria. This is our next module out of the Advanced Test Automation Framework Development course. And this time we're going to discuss troubleshooting capabilities. Of course, before we begin, first subscribe to the channel, hit the ring bell so that you get notified about many new videos that are published each week on the Lambda Test YouTube channel. Also check the Lambda Test blog because there are many detailed articles that can help you to be a much better test automation engineer. In the links below you will find the link to the GitHub repo with all of the source code that we're going to discuss. And before we begin, I suggest to download and clone the repo. It's called Polaris-wide Test Framework. And for this particular course, if you're following it, I'm creating a branch for each particular module. So after you clone the repo, in order to work with this particular code, you need to check out the troubleshooting capabilities branch. And little by little, we are upgrading our solution for each particular module. And I suggest to check this course from start to the end, module by module, because we are upgrading little by little our framework. So this is the course overview. Don't get confused. These are not the exact modules. We have like 12 or 13 modules or so. These are just the bigger groups grouping the modules. And this time, this troubleshooting capabilities is part of the fourth group about operational excellence. The troubleshooting is very essential capability of any framework because, we as test automation engineers, we spend a lot of time when it's not just writing tests, of course, but at the end of each day, we need to analyze the test execution and analyze whether a particular automated test execution failure is a production bug or a test environmental issue or a problem of the test. And there are many features that can be added to any framework that can help us to speed up this process and make it much more automatic instead of spending a lot of manual work each day, because we're going to talk about scaling, and this is not only about parallel execution, but imagine that you have 10,000 tests and even 1% of them, if they fail, it will be a lot of burden to you and your team to make this type of analysis. So through in this particular module, we will focus on these particular features, and we're going to add them to the framework. If you follow me on the YouTube, you will recall that many times we discussed parts of such features like leveraging, for example, toast messages or this exception analysis that we are going to implement again, chain of responsibility design pattern, but we're going to simplify it a little bit. Also, we can, and we'll discuss shortly, the highlighting and other smaller features. But here the emphasis in this particular module will be how to connect all of those features together in the framework in a more maintainable way, using and extending our plugin architecture of the framework so that we don't break everything if we refactor all the time the framework. And building this particular design will help us to extend it even further if needed later to bring more advanced features. For example, we are going to begin discussing how we can add BDD logging. What is the BDD logging? This is a term that I think I came up. Many people refer to BDD using this gherkin syntax for specful or gherkin in Java. This is a special tool writing the tests using natural synthesis, using a regular native language like English. However, in my experience, I wanted back in the past to generate those logs instead of writing the tests using this particular syntax. Instead, when I execute my test, to have a particular log of what happened. For example, I'm going to navigate to this page, then I'm going to click to the element with this locator and type this particular value there, or select this from the combo box or check this particular checkbox. You get that, right? And I was thinking that maybe many clients actually really love it, even much more than other more advanced features, and I was really surprised. And many engineers found it very useful. So this will be the first thing that we are going to integrate into our framework. To go even further, we are going to implement those toast messages. If you are not familiar with the term, these are messages using JavaScript that basically in web, these are notifications that are pop-ups that will show up particular messages. This is quite useful when you're going to see an example in a minute. This is useful when you have a video recording and you print what data you create into the test environment or what you validate on the page, etc. Because many often all of those background operations, you cannot distinguish what's happening in the video. And if we combine that with the cloud execution on Lambda test, this is super awesome, especially when you have a highlighting. After that, we are going to integrate the exception analysis that we developed in the series about design patterns. Of course, I will give you a quick refresh on what it is and how it works. But again, this basically is a solution that will analyze the failures of the test and will print a prettified message about the reason for the failure if it's something more generic. And we're going to add a little bit more troubleshooting plugins, like for example, we are going to mark the test in Lambda test as pass, fail, and also we are going to print there the native C# exception, which by default it's not happening, and we need to create a special plugin for that. Or even we can add a plugin for failing tests if there are any JavaScript exceptions in the console when we execute our test in the browser. So let's begin. Lots of things to cover. First, we're going to discuss the BDD logging and the toast messages. But let me give you just an example of what we are going to do. This is the solution here, and I wanted to show you the BDD logging. I have already executed this particular test. As you can see, we have a logger. This is we printed that on the console. Let me move that here. So we printed that on the console, and as you can see, I added a plugin for mentioning what test we started. Then I have a log for each of the particular actions that we did on the page. What we typed, what we verified at the end right here, with the particular value of what we verified, which is very awesome because many often we are going to generate dynamic data, and this is pretty helpful because every time this will be refreshed with the specific data that you generated. And for example, sometimes there are bugs in the test data setup, and you can provide these logs and add them to the bugs that you are creating in Jira, for example, and this can help your developers to analyze the failure. And if we check the Lambda test platform, again, these marks of pass and failure, I will show you a little bit later the plugin responsible for that. But I wanted to show you something else. Let's play this particular video of this execution. And if we jump, you will notice that we have now the highlighting, right? But also pay attention to the top right corner right here. We have these toast messages. Again, they are very similar to the BDD logging. These are the toast messages that are showing every time what we are doing, what we are verifying, and also we are scrolling down, and it's completely visible, which is awesome. In a minute I'm going to show you how we can implement that. In the past, in one of the Java courses that we had on Lambda test, I showed you how we can integrate something similar using the WebDriver listener. However, the WebDriver listener class, it's much more generic, and it won't work for many of the parts of our framework that we have now. Since you can subscribe to events, general events, like clicking any element or typing in any element. However, if you recall the module about our complex components, for example, table, grids, and that are heavily using JavaScript, actually we don't have events for that. You have a general event for executing JavaScript, but like you don't have an event for setting an attribute, or even if you have one, it will be super generic, right? This is why we will have to create and use observer design pattern or its native implementation of event and delegates in Java. For that, we'll see how it goes. I will show you. And something more, as I said, a little bit later, I'm going to show you how we can send, as you can see, I filtered assertion errors here. Let me refresh. This test failed, and it's marked not as complete, but as failed. And we can view all of the native exceptions here, right here. As you can see, this is directly pointing parts of my code where my test failed, which is awesome because it can help us to, again, troubleshooting much easier instead of going through different platforms to see those exceptions. For example, before implementing this plugin, I had to go, for example, in my continuous integration tool to view the exact exception, then switch to Lambda test to view the video, and then go to my code. Now I can just go directly to Lambda test, view and filter all of the failed tests and check the exact exception, which is awesome, and I will have the whole stack trace. Again, we're going to implement such a plugin, reusing the current design of the framework. Now let's begin, and let's see how we can implement this type of, how we can support the BDD logging and the toast messages. For the toast messages, I'm going to use this library. It's called 𝑗grow. So we are going to use JavaScript, of course, and we will have to add to every document this link and script tags. As you can guess, since you're going to use your own application, probably in 99% of the time, these scripts in CSS won't be available there. So we need to find a way how we can add that to each particular page before you do particular actions, so that we can use the syntax later to throw the 𝑗grow messages. In order to do that later, I'm going to show you that we are going to create a new service utilizing the new integration in Selenium about CDP, or Chrome Developer Tools protocol. It has a capability for pinning a script or executing a script and initializing it for each particular page. So we are going to create plugins about that as well to create the toast messages. As you can see, there are a lot of parts that we need to utilize, but that's fine. This is why, as I said, the most important part about this particular module is how we can integrate everything and create this particular design so that we support this type of extensibility and plugin architecture. Otherwise, your code will be full with copy-pasted code and it will be a maintenance hell later. We are going to use event and delegates inside our components. As I said, we're not going to leverage the WebDriver listener class. Instead, and actually the event firing driver, which is responsible for triggering those events. And I'm also going to use this time the native support for the observer pattern in C#, utilizing the event and delegates. Now, what are the event and delegates? You will find a link to this article of MSDN, handle and raising events. So in C#, the observer pattern is often implemented using this event and delegates. This pattern allows an object called a subject to notify a list of dependent objects, observers, about the state changes without knowing who or what those observers are. Again, in C#, these events are a way to provide notifications, and delegates are like function pointers in C++, but they're type-safe. And an event delegate is a delegate specifically used with events to provide a mechanism to bind event handlers to an event. Maybe this sounds a little bit more complicated than it is, but in a minute I'm going to show you how we can do that. So for the job, I'm going to create here two folders. One of them I will call event, and I will create one more that I'm going to name event handlers. Now for the event handlers, for the events, I'm going to create two classes for holding the data. One of them is called component actions event argument. We are going to use this class to basically hold all of the data that we are going to provide to our observers. Basically, this is like a grouping for of the data. In this case, when we trigger such an event from a component, we will hold a reference to the component itself and the action value. What is the action value? The action value is the value that we type in a text box, a number that we pick in a number box, an email that we type in an email input, or I don't know, a value from a combo box, or something that we verify in a diff. However, some of the events that we are going to trigger, for example, when you click an element, they don't have an action value, and this when we do that, we will use this particular constructor that, as you can see, it doesn't accept an action value, but instead it's just accepting the I component. So inside each component adapter, we are going to create static events. Why static? We use static events because it will be easier to subscribe later. The subscription is when you add that. If you recall the video about observer, and when we created the plugin architecture, we had a list of all of the methods that we are going to execute at particular point. Basically, through the event handlers, we are going to subscribe or add methods that will be executed, and we do that with the operator +=. So here we use the special keyword event, and then we have this generic class part of the system namespace called event handler. And as you can see here, since this derives from the base class event args, we provided our custom arguments that this event will use, this event handler. And after that, I'm going to change our base class here, that it's part and located in our base class for all of the components, the web component class. And this is the place where we are going to trigger this particular event. So I'm going to change the signature and I'm going to provide the actual event handler that we need to trigger here, the actual event. Why I use default parameter here? Because I don't want, by default it will be null, and I will mention don't trigger the event, don't fire it, don't invoke it if it's not initialized. If it's null, don't invoke it. And this way, even if somewhere I haven't provided the clicked event here, there won't be an exception. I won't need to fix it everywhere in my code. So I'm going to invoke here the clicked event, and again, in order this logic to work with with the if statement, I'm using this special operator, the question mark, and this question mark dot means that if this is null, this won't be invoked here, this won't be executed. And when we go invoke, this will execute all of the event handlers that we subscribe to this particular event, and later we're going to create event handlers for the BDD logging, for the toast messages, and later in more advanced frameworks like the ones that I developed for some of the enterprise projects, we went even further, extending this idea, and instead of only having the BDD logging, actually we have something called dynamic test cases. These dynamic test cases are actually integrations with test case management systems that if a test case is missing there, we are going to create with the API a test case with the name of the test, with all of the basically actions that the test is doing with the exact data, and we will have also validation steps into the real test case. And not only that, but if we for some reason update later our test and add new actions or delete some and we refactor the automated test, with every execution when the test is green, we are going to update this particular manual test case in the test case management system, whether this is 𝒏𝒕𝒐𝒏 that it's a very popular test case management system as a plugin for Jira, or Qtest, one of the maybe best test case management systems, no matter, or Azure DevOps. It works for all of them. So we can update later this manual test case. And even more, if depending on how you integrated this, you can have creating an execution for all of those manual test cases and having that. Again, it depends on the flow and how you use the test case management system. But again, this is leveraging the same design. This is why I'm saying that this module is about this design in the framework, and it's important to understand how this works. And we don't need every time to go and refactor all of the methods. Instead, we are using this plugin architecture, and we are upgrading that to support it. So we're triggering here, and also, by the way, another usage. You can, if you are sure that your tests that you are executing are super important, for example, you can have 20 of those tests that are executing every day, constantly. They're called sometimes smoke test suite. If something fails, you're completely sure that it's a bug. Maybe we can leverage the same design and architecture to create plugins for that, to create automatically Jira bugs, and adding all of those steps, BDD logs, screenshots, videos to the bug, and assign it to someone. And this can be automatic. Again, you need to be really sure that your tests are very, very stable in order to do that. But again, this is something that I have implemented in the past, and it works and it's doing a great job. again leveraging the same design. So here we are triggering the event. We can do something similar for the default method for typing the text. Right here I'm going to provide the event handler, the text set. As you can see, it's no. And after that I'm going again to trigger the same event here after we type the text right here. In some designs, some people prefer to have two events, one before of the actions and then another after the actions. And to be honest, in designs of the frameworks in the past, we have added both of them. However, through practice, we found out that actually nobody is using the event before of the actions. It's just, I don't see a practical usage of that. And usually we are triggering all the events when the particular action happened, whether this is clicking of a button or typing text. Now, all right, so I added that to our base web component adapter. And next, if we go again to our anchor class, you will notice that here now this is underscored, right? And it says that already we actually updated the signature of the method because it has a default parameter. So it doesn't make sense now to have this new keyword. So I'm going to remove the new keyword, and I'm also going to provide our clicked event. And I'm going to do something similar for the button. Again, I'm going to create a new event handler. I'm going to provide here the event handler, but be careful, we have totally different events here. You cannot reuse them. And you will see, for example, for the checkbox, we'll add event handlers like checked and unchecked, or for the date component here, we're going to add date set. We are going to add something similar for the validations, etc. Again, here we need to remove the new keyword. Here it is, the checkbox. We don't, again, the whole point of having separate events is that, again, instead of using the event firing driver, we are going to leverage our custom event and event handlers. So here now we have checked and unchecked, and in the methods below, we are going to add them. For example, here I'm going to invoke the check and checked, and after that unchecked. Like that. And the way we execute that, by the way, is that this invoke method, it accepts as an argument, as a parameter, this is actually the current reference to the object that it's firing the event, and then the second object always are the event arguments. So we are creating a new instance of our custom event arguments, and we are executing, and actually we are using the first constructor that it's accepting just the component. For cases like our text field, right here, again, we need to remove the new keyword. For the text field, we are going to use the text set, and yeah, like that. Again, we have something, it needs to be in past tense because it's executed after the action. And for example, for the date here, we are going to use the our second constructor. As you can see here, we have date set event, right? And I'm going to invoke it right at the bottom. This is a great example of how and why this cannot work with event firing WebDriver. Again, here for the date HTML5 component, the input, it doesn't work with send keys because we're setting the value attribute. And in many of the complex controls where we use this complex JavaScript to control how we set values, how we get the data, etc. If you throw particular events, if you fire them, you cannot subscribe to anything meaningful in the event firing driver, because the event firing driver, it provides just super generic methods. And in this more complex context, this is not working. Don't get me wrong, the event firing driver is super okay for most of the cases, but in such more complex setups like this particular framework, this won't work. And this is why we need to implement it ourselves. Alright, so after we implement the rest of the components, we can create some base classes. For example, the first class that we need is one abstract class. I'm going to add it here in this particular folder. Is this abstract class that it will be the base class for all of the base classes that we are going to leverage to allow our users easily to add methods and implementations for these events for the components. And let me show you how this will work. Now, for all of the event handlers, I will have a specific base class for each specific component. Like, for example, I have one such base class for the anchor, for the button, for the checkbox. All of them are implementing this abstract class, which we need to override the subscribe to all and unsubscribe to all. Again, we are using this special operator here. This basically says add this, subscribe this event handler or a method, add them to the for each statement of this event. And when you fire the event, all the subscribed event handlers will be executed similarly to how we implemented the observer design pattern, where our execution engine actually for each all of the observer specific methods in each particular point. Again, this is just something built into the language. You don't have something similar, for example, in Java. But this is like you're using a lot of code, which is excellent. Again, we are overriding those abstract methods. In each of them, we are just subscribing to this static event or events that we added to the components. And then we are providing a protected virtual method that, as you can see, it's empty. This is the method that we are later going to override in each specific implementation. We will have one child class for the BDD logging, one more for the toast messages. Later you can have and add more for example, dynamic test cases or automatic bug logging system. Yeah, and I did that for all of the components. Nothing really special, but we're going to reuse all of this boilerplate code where we're going to subscribe to the events. One more thing here for the validations. I think one of the biggest benefits of this particular design is that we'll see again in the video, as I told you, especially for the toast messages, we are seeing exactly what we are verifying on the video. In order to accomplish that, if you remember, our validate methods are something very specific about we are waiting for something to happen and we are validating it. They're like dynamic assertions, and we're waiting for the specific thing to happen. And here to our extension methods class, validate component extensions, I added for each of the specific validate methods a specific event handler. As you can see, we have validate is visible, is not visible, value is, inner text is, etc. And then after the actual validation here, calling the wait until, we are throwing the specific event here, right? Of course, pay attention that, again, for most of the parts where, for example, we are checking whether a value contains something, I have called the second constructor here, providing the actual value that we are asserting. This way, I will have access to this particular value and print it on the console for the BDD logging or in the toast message. Again, this is an information that we need. However, if you are checking just whether something is visible, then we don't provide that into the constructor here. Also, one more thing to pay attention: if for some reason this fails and the information is wrong, this event won't be triggered, because here this particular logic will throw an exception. Maybe this is something. This is maybe one of the reasons why you may consider to have one more event before the actual validation, so that you log that before actually executing the logic. But again, it will be up to you and what you want to do. Now, let's switch to the actual implementation now and don't lose time more. I have implemented already in the browser that I told you about the troubleshooting capabilities. I already implemented these child classes, implementing these event handlers. As you can see, this BDD logging button event handler is deriving from the base class that I showed you about, the button event handlers. As a user of the framework, I can do that in the my custom project outside of the framework. This is completely fine. The designs support that, and we're using that for many clients actually. Again, we are deriving from this base class, and we are just overriding the protected method clicked event handler. In this case, as you can see, I'm using a special class logger. In a minute, I'm going to explain what this logger is. It's something important that I have already added to our core project. It's something that we can leverage across our framework. But as you can guess from the name, this is a logger that will log messages to the console, to the debug output, to files, and to other systems. In this log info, as you can see, we use string interpolation with this $sign in C# instead of string format. And we are going to say click, and this will print that we are clicking on the element with this find strategy. Now, in order this to string syntax to work, as you know, we can get the actual value of the find strategy, like the actual XPath or the actual ID. But if you just print the ID, it won't be clear to you directly from the message that this is an ID or it's not a class or something else. This is why, in order this toString to work, if you don't override the toString method of the specific find strategy, this will just print the name of the class, like ID find strategy or XPath find strategy, and it will be super useless. In order this to work, I overrided the toString method for all of the find strategies. As you can see here, I overrided the toString method that comes from the base class of all objects, the object class. And when you call toString, this will print XPath is equal to the actual value. I did the same for the rest of the strategies here, ID equal to something. So if we return to the BDD logging again, let's see now how this logger is working. In order the logger to work, its static utility class, I added it here in our core project. As you can see here, the core project, and I have a namespace logger, and I have a static logger class. We need a few NuGet packages. I'm using the default way to do that in .NET. In .NET Core, I installed all of these related NuGet packages coming from Microsoft.extensions logging, logging abstractions, configuration console, and debug. Also, all of this infrastructure, it supports integration with other open source loggers, and in this particular case I prefer working with the open source logger called 𝒐𝒏𝒕𝒐𝒏. So I installed all of the related and needed NuGet packages for it. Again, we're going to support logging to console debug, maybe to files as well. This is pretty useful sometimes, for example, for the files to send them via email or to attach them to a bug report, or sometimes when you debug, it will be better for you just to observe them here in the output, debug, etc. When you have the console, as you saw, we are going to print the BDD logging into our continuous integration or directly integrate that into the Lambda test as well. Now, I created this static logger class, again, this utility class, again here. So we have a static private read-only variable to the iLogger, which, as you can see, comes from the 𝒐𝒏𝒕𝒐𝒏. And we have, again, logger configuration needed for creating the logger itself. So this logger configuration is responsible for initializing the logger itself. And you will notice that now I have these global settings. If you watch the module, if you miss it, check it out, about the configuration management in our framework. I showed you two ways how to do that, one with JSON files and another with static classes. Similar to this 𝒏𝒏𝒕𝒐𝒏 class, right? This 𝒏𝒏𝒕𝒐𝒏 class, it controls the behavior of our web project. We have a similar one for mobile. Explicitly, I added some new properties here that we are going to leverage in a minute in the plugins that we are going to create. So we have a property for controlling whether we have BDD logging, property controlling whether we have highlighting, whether we need to scroll into view, whether to enable toast messages, whether we have screenshots on failure, whether we want to enable the exception analysis or check for JavaScript errors. Again, many plugins that I'm going to show you quickly at the end of the module. However, it doesn't make sense to repeat every time the configurations for the logging inside the web settings, the mobile settings, desktop settings, API settings, and every time, right? Since they are static, we cannot create a base class for that. This is why I added this global settings class that will hold just static properties to everything that it's common and shared across all of our modules, whether it's API, web, desktop, mobile, right? For now, this is just the logging settings, but later we're going, when we talk about reporting solution and result frameworks, we're going to add these settings here to our global settings. And yeah, so I created this logging settings class, which basically have a global switch for enabling the logging, and whether we want to enable the console logging, the debug logging, the file logging. And for now I have just a single output template. The output template is something controlling how our messages are formatted. For example, here, as you can see, whether you want, for example, to have the time here, maybe you can strip that. If you don't want the time, you will remove this particular thing. Also, you can control the level of the logging, whether we want to print only errors and warnings or everything. Whether you want just the message, a new line, the exception. So you have a lot of flexibility. You can provide a different output templates, as you'll see in a second, for the console, debug, and file. For now, I just use a single output template. If you want, you can extend these particular settings to support that. So if I go now to the static logger class, you will see that I leverage a lot this static global settings class, and based on it, if it's enabled, I am enabling, and I use those switches inside these if statements, and basically I check the 𝒐𝒏𝒕𝒐𝒏 documentation, how I can enable, for example, the console logging we're providing the output template. Again, this is a string for how we want to format that, and I'm just enabling the console, the debug, and the file. After that, I'm leveraging my private static variable to walk information, and we use this syntax with the params object. By default, you don't need to provide any arguments, but this supports a format similar to string format that you can leverage placeholders to format the message. And that's it. After that, you just use wogger.walkinfo. This particular architecture, when we leverage again the Microsoft abstraction and this static utility class with the global settings, means that later, imagine that this open source project in a year is abandoned and nobody uses it or support it, or there is a critical security issue there, and for some reason you want to check and change the logger. That's fine. You'll go just to this particular class, you will update that. You won't change the signature of your static methods. You'll just, update how this internally works, but you won't need to update nothing else. The only reference to the 𝒏𝒕𝒐𝒏 is here, and that's it. This is the benefit of having this core project, because you will leverage this particular abstraction in utility class, and we are going to utilize it later. And again, in our BDD handlers, let's see them again, that we have implemented right here. We are leveraging this logger walkinfo. So I have one for the clicking. Again, for example, for the checkbox, I have implemented both of them, the checked event and the unchecked event. However, you're not forced to implement all of the event handlers or to call them all of them. You can pick whatever you want. For example, as you can see, for the validate exception event handlers, I have implemented all of them here. It's nothing more than just having these particular messages here formatted right. Now, for the toast messages, before we move to the actual implementation, you will notice that they work in a very similar manner, right? We are just, again, implementing those base classes here. We are overriding the event handlers, for example, for the checkbox, and we are just using the driver adapter. This comes from for our partial class about the browser service, where I implemented these toast messages. Just in a second, I'm going to show you how this works. But we have the messages here are the same, but just the logic how we trigger those toast messages is different, and we are using JavaScript, as you will notice in a minute. But before we move to that, let me show you how we actually integrate that into our tests, how everything connects together. The way this works is that if we open our tests, like this class and the method that I executed, everything happens inside our web test class. That, if you notice, comes from our web project. It's under the core namespace and unit, and you can do the same for MS Test, of course. So this is the place where we basically connected our observers to the plugin execution engine, yeah, I added many of those. I will explain later what those additional plugins are, but for now the important part is these two methods, add BDD logging and toast messages. The way this works is that right here I have two static methods, add BDD logging and add toast messages. You will notice that again I leverage the new static properties that I added to my web settings class, and whether the BDD logging is enabled and whether the toast messages are enabled, right? And the only thing that I do here is that I'm creating a new instance of all of those classes that I created here, and I'm calling their base subscribe to all method. Basically, for the BDD logging, this will subscribe this particular event to the button clicked event. And this is how we hook everything together. Again, this logic will be executed every time when we execute our tests. However, it will be based whether this will be executed or not based on the key here, whether this is enabled or not. And if you recall, we have a special class called web configuration loader that based on the configuration we picked and switched through the CLI, we are going to load different set of settings. And for now, for the development, I added all of those settings here and I enabled everything, right? But and again, I called here the global settings as well. As I said, we are using them all together. Now, in order these toast messages to work, I have created and extended our browser service. If you recall, the browser service is part of our driver adapter here, and this driver adapter, I have added new methods called error toast messages, warning toast messages, info toast messages. And as you can see here, yeah, actually I have an error here. So depending on whether the toast messages are enabled, we are going to execute a particular JavaScript. In this case, again, we have a method execute. Actually, the magic is happening inside the prepare script. In the prepare script, the whole thing is that we are waiting for this jgrow to be initialized and to be there. Then we are escaping the JavaScript. Why are we escaping it? Because otherwise, sometimes depending on the signs and the letters that you put into the messages, sometimes this won't be a correct JavaScript and we need to escape it. So I have a specific method called escape JavaScript string. And then we're just formatting everything. It's just a single line of code to trigger the jgrow toast message. Again, you can check that everything inside this documentation. Basically, if you do that inside the console, again, if you have the links, these two links into the head of your web page, after that you just need to type $jgrow and then the message, and then the toast message will be displayed. Again, depending on whether you want, there are some settings here that you can utilize, and you can check the documentation, but you can use it pretty easily. However, as I said, it's not the problem how we trigger and start these particular messages inside our framework. This is easy because you just execute a JavaScript, right? But first we need these two scripts to be added to every page. In order to support that and execute that, we will leverage the WebDriver bidirectional script feature. Again, this was added in the Selenium 4.0 release. However, here the documentation is completely missing in some places. But we are going to utilize this Chrome Developer Tools protocol. So CDP in short is this Chrome Developer Tools protocol is a set of tools that provide the ability to instrument, inspect, and debug and profile Chromium-based browsers like Google Chrome and Edge, and it offers a way to interact with the browser at a deeper level. And in Selenium, CDP can be used to perform tasks that are not directly supported by WebDriver API, but again, some other libraries like Playwright, they utilize it quite extensively. So we are going to use this pin script feature to utilize that. So I have added a new interface to our driver adapter. It's called 𝑣𝒏𝒕𝒐𝒏. In future modules, we are going to extend much further that, adding a lot of features regarding performance, checking memory leaks, working with network, simulating network conditions, and more. Again, if you're curious, we have on the Lambda Test YouTube channel a whole course in Java about many of the specific features about Chrome Developer Tools protocol and bidirectional APIs. Right now we are going just to implement this at initialization script. In order to do that, in our driver adapter, where we get a reference to our wrapped adapter or the current iWeb driver, I'm checking if the web driver is not null, and if the web driver is implementing the iDev tools. Again, for example, Firefox or Safari, they are not implementing this interface. This will work only for Chrome and Edge, so be careful. We're creating a new dev tools session with this particular method here. We are initializing these two properties that are part of the interface, and we're getting the specific version of the domains. Again, be careful because this will work only for a version of or a tool of the specific browser, and especially when you execute this code in Lambda test, you need to make sure to match the versions. Right now I have eased that in our framework, and in our global using class here, I have added all of those global usings with the particular versions, right? In this case, this is version 125. For this feature with the pin script, we are going to utilize this particular global using that is part of the page domain. Now, there one more specific thing in our driver factory. You need to make sure when you dispose the driver, not here, driver factory, but in web, right here at the bottom, when you implement the dispose method, you need to make sure to check if this is DevTools, then you need to close the DevTools session. Otherwise, there might be some problems. After that, I have created two plugins that are really important for the highlight and especially for the toast messages. So these two plugins, let's see them. Again, they're part of the plugins namespace here. So I have two plugins, initialize highlight script and initialize toast messages script plugin. I'm going to show you the initialize toast messages plugin. Again, this is something that we are going to subscribe in our base web test class. As you can see, this will be executed on before test initialize. And the thing that we do here is that we are checking are the toast messages enabled? If yes, then we are getting the DevTools service part of our driver adapter. We are getting the dev session domains, the page domain, and we are sending that we are enabling this particular domain, the page domain. And after that, this page domain, it contains this particular method add script to evaluate a new document. In the C# version, all of those methods, part of the CDP, they accept settings. They are implementing the command design pattern, and the commands here are actually these command settings classes. In this case, this particular command class, it has just one property called source, and we are initializing this script to the source. The thing that we are doing here is that we are saying when we're subscribing to the onload event of the page, meaning that when you load the page, this script, this method will be executed, this anonymous method. Or basically we are checking, do we have jQuery? jQuery is required for jgrow, so we need to have both. If we don't have jQuery on our website, we are going to implement a script tag, and then we are going to add jQuery to the script tag. After that, we are going to initialize the $, which is the main thing part of the jQuery library. And after that, we're going to load the script part of the 𝒌𝒈 here and its CSS. We are going to add it to the head as a link to the style sheet. After that, when we are here and we execute that, this method will be available for you. This method will be available for you, this 𝒌𝒈, right? Otherwise, if you don't do that, the scripts won't be there and nothing will happen, right? I have implemented absolutely the same thing about our highlighting plugin. If you remember, we have this highlight element plugin that we implemented in the previous modules. It's responsible for highlighting for a short period of time the elements that we are clicking or typing text into. And before we were executing this whole script, I mean, it's fine to execute it every time, but this time I just wanted to show you one more instance in practice how we can utilize the pin script. So I pinned this whole thing inside another plugin. It's called Initialize Highlight Script plugin. In a second I'm going to show you. So it's initializing this method for us every time, and this is why I can make much shorter our plugin now. We just execute here this script because I already have the highlight method. It's initialized, so I can execute that. It's excellent. So this initialize highlight plugin, it works the same way. We are getting the DevTools domain page domain, we're enabling it. We're again, be careful because most of the methods here are actually asynchronous. So we go wait to wait for them to be executed. And I'm doing the same thing here, but I moved the highlight logic here and we are pinning it on every particular page. And the way this works and the way this is hooked is, again, in our core project, I have added those plugins right here using our plugin execution engine. I added them to the whole execution chain. Now, what else? I wanted to show you, if we move to our presentation, the second point was about implementing the exception analysis, that it's implementing the chain of responsibility design pattern. Again, here I simplified a little bit. It's not like the full implementation, but I implemented it a little bit more simply. The whole point about the exception analysis is that when a test fails for some reason, we have some handlers for checking what is the actual, these handlers are here. So we have handlers for checking whether we have JavaScript console warnings, whether we have JavaScript errors. Later, when we implement the features about capturing all the requests, maybe we can capture all the requests and check the responses. If something fails, maybe we can fail the whole test. We can check for specific parts of the HTML, if it's server unavailable or something else, or particular exception URL. Maybe we can fail the test. So we have a handler, again, containing a detailed message explanation that will we are going to provide to this analyze test exception, custom exception. Again, it will format in a very friendly manner with new lines, with some dollar signs. It will just print a prettified message of the problem that the handler catched, and maybe we're going to print the URL as well. And all of those handlers are implementing this base class, whether it's applicable. If it's applicable, basically here, for example, for the no failed request handler, we're going to check later whether there are any error codes, right? Again, later we're going to fix that. Or if there are any JavaScript errors, again, this is something that we're going to add in a minute. or whether there are some console errors, or whether something is available in the HTML source code, for example 404, or service unavailable, like that, for example HTML source again. And the way everything works here, again, in the links below you will find a very detailed video about that, about this pattern, and this is why I'm just going a little bit quicker here. I have implemented the pattern in a more simplified way. Basically, we have a list of all of those handlers. We have a link to the adapter. We have methods for adding handlers to this list. And then the core logic is executed here in this analyze method. Again, it will just for each of the handlers, it will check whether the particular handler is applicable or not, providing the actual exception that our test failed or our framework throw. And then we are going to print the formatted exception if this exception handler is applicable. The way we hooked all of that, this exception analyzation, is that I created a plugin. Again, the important part is how we plug that into our framework. It's not, again, you can watch the specifics of how this pattern works. And the way this works is, again, if we open the plugin namespace here, the folder, I have a new plugin called exception analyzation plugin. It's very simple. On after test cleanup, we are implementing again the base class plugin. I'm checking, is the exception analysis enabled? If yes, I'm calling my static analyzer here that will start the analysis. It will start the for eaching and the chain of all the handlers, and maybe if some of the handlers is triggered, if it's applicable, we'll throw the prettified message, and this will ease the analysis of the failures. Again, in order to add all of the handlers inside our base class here, the web test about NUnit or MS test, I'm going to add those exception handlers and the handlers that we want, or whether we have custom handlers, we're going to add them here to our static class. And also I'm going to add this plugin, I'm going to enable it, adding it to the plugin execution engine. And one more thing, maybe lastly, if we want, in a few occasions I showed you how we can mark tests as passed or failed in Lambda test and send the exceptions to the Lambda test cloud. This is very interesting. We have this plugin, Lambda test results plugin. Again, I'm mentioning it again here because it's important for the whole suite of troubleshooting features. So after the test cleanup, we're checking, is this a Lambda test run? And if the test passed, then we're going to execute this particular JavaScript. Lambda test status, again, I checked that from the documentation, and we are marking the test as passed. If it's a Lambda test run, and if the test is failed, then we are going to create this list of strings containing all of the exception stack trace and messages. We are going to mark the test as failed, and we're going to do a second call called Lambda test exceptions, and this will send this particular information to the Lambda test cloud for this particular session and test. And later we're going to see that the way I showed you in the demo before, which is excellent and is definitely something that we need to integrate. Be careful though, when you add all of those plugins, the actual sequence of adding them to the execution engine matters, because we want this plugin to be registered before the execution of the browser lifecycle plugin. Otherwise, we're going to dispose the session, and later you won't be able to send this information to Lambda test cloud. This is really important. Lastly, we can again implement JavaScript errors plugin. Part of Chrome and Edge, actually we can get some browser logs from driver manage logs get log browser, and we can filter them to get just the errors of them. And if there are any errors, maybe we can fail the test printing a certified message. Again, you can do that with this JavaScript errors plugin, or you can utilize the exception analyzer. It will be up to you. Just don't forget that when you initialize the Chrome options and the Edge options, you need to set this logging preference to enable the logging before that. Otherwise, this won't work. And you can, when you download the code later, you can view, we already discussed in previous modules, the scroll into view. This is again part of this suite of troubleshooting features. This is important when you watch the videos on Lambda test. This will scroll the browser to the part, especially for bigger pages where something is not visible in the visible part of the viewport. This will scroll and make it visible for you on the video, and you will see the actual toast messages. This is something really useful, and I encourage you to enable such a plugin and have it. If you don't use a platform such as Lambda Test, maybe you can check later how I implemented a plugin called Web Screenshots plugin. This is something that basically we are going to make a screenshot with the native capabilities of WebDriver, and we're going to save that screenshot on a particular part of our drive on our local machine. Again, I will leave it here because we're talking right now in the context of the Lambda test execution. There, for each particular action, if you enable the visual logging, you will have a video and visual capture for everything. Maybe you won't need that. Later, if you create something like automatic bug creation or something similar, it might be useful for you to attach that to the bug reports or to upload it to Azure. It will be up to you. Or later when we implement and talk about result frameworks and portals. All right, very long module now, but it's very important. Why this is important? Again, the troubleshooting features, they're really the core of your framework, because our time as test automation engineers is not only spending time on writing tests, but actually a lot of times, like 1 hour, 2 hours per day, we're analyzing failures and logging bugs, etc. And it's really important to have such a suite of features inside your framework to help you to minimize that time and give you more time to write new tests instead of maintaining the rest of the test suite. So we saw how we built this design into the framework to support and leverage new features and plugins like the BDD logging, the toast messages that are really great for enabling to see what the test is doing inside the console or the book or in a file or inside the Lambda test in YouTube in videos of the test execution. Also, we integrated the previously developed during the design pattern course exception analyzer into our framework, and we utilize the Chrome Developer Tools protocol to ease the execution of the JavaScript to enable the support of these toast messages using the pin script, and later we are going to utilize that for other features in our framework. In the next module, we're going to start building the core components for API. We're going to leverage most of them for test data management, so check it out. It will be quite interesting. Thank you for watching. If you have any questions, put them in the comment section below. Also, don't forget to check the Lambda test blog and the community website, and don't forget to acquire your free certification about JUnit, NUnit, WebDriver, APM, and many other technologies from the certification program of Lambda Test. Thank you for watching, and see you in the next module.